Hey everyone, and sorry for our little delay, but now everything is working. So Kevin and I, we are here from the Build Guild, and we are here kind of to show you a very nice prototyping tool, Scaffold Eve, and also the education around it and how you're getting ready in order to build some. Oh, remind me later. Sorry. In order to get some educations, some applications, and that's kind of the build. Oh, I need to. Can I put the microphone a little bit? Does it work like this? Or do I need to go like that? I don't know. Okay, perfect. Is it good like this? Oh, okay, perfect. I was a little bit confused. Yeah, that's kind like like you see from the guild what we have the educational perspective and the tooling perspective. So I keep myself a little bit shorter so we have more time than going more into the tooling, and that you can use the tool for also for the hackathon. What is very cool, what I always use when I be here and build some things. It's definitely pretty nice. Yeah, and what is kind of our background? I think the whole thing, and that was also for me very, very important in the beginning. Then in the beginning, you're starting to build and you have all this theory in front of you and you're looking through, okay, this is a solidity contract, but how does it really work? How it will get deployed? How the heck will I have even an app out of that? It's just very overwhelming in the beginning and you really don't know what to do. And then there's also the other thing, you're gonna see, okay, there is DeFi and there is so many stuff out there, you don't have really a clear path, which way you should head in which direction. And then you're looking at all these concepts out there and they're kind of all isolated. So you don't really know how to bring them together. And it was kind of Austin who came up. He said, okay, we definitely need to make builders more ready to bring all the concepts into applications. So we kind of foster the application layer of Ethereum because we just have not enough applications. I mean, we have so much block space. We have so much nice protocols, layer 2s, all there, but there are just no applications for that. And that's why we kind of came up with a curriculum. So we have in the beginning, so all the way, we're having Speedrun Ethereum. I don't know if you've heard about it, but it's pretty cool with kind of the challenge. I will go into it and just flip it a little bit through what you're gonna learn. And out of that, when you're doing this, you have the chance to join the batch program. That's kind of a program hosted, curated by me and another guy, where we're teaching people everything around how do you work in the Web3 space. Because besides just building on your own, it's also very important to know how to interact with people out there and how you're building together to build some stuff. And one very important skill is definitely GitHub. How do you make the right PRs? How do you write issues? How do you not just work randomly on stuff? And so we are kind of pretty rigorous with the reviews, and we just make sure that you're kind of getting the skills out of it in order to build then collaboratively with other people. And when you're doing this, there's also then we encourage you to have some more builds. You start build your own project. You have a call with me where we kind of just going through your concept and you're starting to build, and then in the end you're gonna pitch in front of Austin and the crew. And then if it goes further, we have grants where you could apply then for other applications, so you want to continue building. And also we now have kind of a launchpad group, so we kind of grouping the most motivated builders together in a group. And every month we're having a call together where we discuss, okay, what have you done this month? What did you build and where do you want to go? Do you want to be a founder? Do you want to become an employee somewhere? And then we just try to kind of coach and mentor you in the right direction. And yeah, and before you kind of start, it's kind of really cool to do the speed run. So everybody who comes to me and say, I want to start building on Ethereum, I always tell, just do the speed run. And that's exactly what I did as well. And as you can see, we have kind of challenges from the beginning to up to very complicated challenges, and you can just jump in immediately. So the first challenge, you don't really need to do much. You're just going through, and on the way, you're building it, you're just getting better. And the real cool thing about our curriculum, I mean, there are many out there, many where you learn Solidity and so on. What is definitely very special about what we have to offer is that with every challenge you solve, you're having a real application out there. So you deploy it on Vercel, it's out there, and you can then even use this as kind of a prototype or the first template, and you just can tinker out, you can add stuff, because you have already things deployed in Vercel, on the live network, and that's actually pretty cool. And that's what I really, really enjoy about the speedrun myself. And just going a little bit through the different challenges we have and what you're gonna learn. Just don't take so much time. We're having kind of in the beginning, you're starting off, you're learning everything about NFTs. I mean, it sounds a little bit boring, and everybody thinks, okay, what the hell with these these JPEGs nobody need, they're out there. But actually, it's kind of a very important base for the whole space, kind of, because you can use it in so many other ways, also in DeFi a lot, and so on. Then also, and then the next challenge, then our staking app is really about how you kind of using a smart contract and how you interact with different smart contracts, and you send in funds around. That's pretty cool. There you're realizing the first how all these Lego and all this works together, and all these construction, these applications on chain. Then it goes a little bit further, and it gets a little bit more difficult. It's kind of the token vendor, where you then kind of learning the base before you then jumping into the DEX challenge that comes then later, where you kind of swap in and out tokens. And you have also looking into randomness on chain, because there is just literally, or there used to be no real randomness on chain. I mean, there's still no real on chain, and that's coming the first time that you're in contact with oracles, more or less. Yeah, I don't know how deep I should go. I wanted to go a little bit in the concepts to explore it to you. I don't know if this is helpful or not. I mean, since we are a very small audience, just let me know. Should I talk a little bit deeper, what kind of an AMM is, how that works? Or should we just skip that and it just kind of round everything up and maybe and show you some other things, how Speedrun Ethereum look like, and then we would head to Kevin? I don't know. It's about you. I mean, we have a very small audience. Just hands up who wants to go a little bit more into the concepts. 1, 2, and the other 3, 4. Oh. Okay, I mean, yeah, I just don't want to bore you, you know. That's why and the cool thing now is, so it's not really much people, so just ask questions, and I can go a little bit deeper into the concepts, because, I mean, what I wanted here to show you a little bit is this automated market maker. I mean, this is an AMM, and this is like Uniswap v2 kind of works, and I would say that's kind of really the basic concept, kind of. I mean, of course, you have these ERC20 token standards and tokens, but really when you're starting then doing something useful on chain, such an automated market maker is very, very, very important. And it's just actually a very simple concept, and I really like. I mean, you can just think of, there is kind of a pool, and I put there the apple and the purse inside. And that's exactly only what it is. That's kind of the Uniswap pools, liquidity pools. And now imagine you want to get a purr out of it. You put an apple in, and you're taking a purr out. And what that does, when you see the graph on the one side, it gonna moves kind of up the x-axis, kinda. This is the x-axis. Now I'm confused. X, Y, X is down, up. The y-axis. Sorry for that. Yeah. Yeah. And what it means when you're taking out a pear and putting an apple in, because pears getting less and apples getting more, that leads that the pear prices go up. And now maybe people thinking, okay, now it's a good price. Actually, the pears are a lot worth more than apples. Let's put me a pear in and take an apple out, because it's a kind of a good deal, and I can get otherwhere a more expensive apple and kind of do kind of arbitrage thing. That's kind of an AMM, and that's actually pretty cool and pretty simple, and that's what we teach you in the Challenge 4. I mean, that's pretty amazing when you're there already, because it's kind of really the base of other. It's a very important building block. And when we then continue further, it's kind of we're doing over-collateralized lending. Over-collateralized lending, maybe every one of you heard about it. That's kind of Aave works, and we're gonna teach you how you can build a lending protocol where users can deposit assets and also borrowing against these assets and earn interest rates on that. And that sounds in the beginning very easy, but actually what is behind it and all the mechanics and what you need to think about it, about who can attack your contract, and so gets very difficult. Yeah, I mean, we're looking in that in a lot of lending and debt tokens. You need to do interest calculation, interest rate strategy, price oracles, collateral ratio logic, and liquidation engine. I mean, that sounds now very complicated, but kind of these things you need all to bring together, and then you have your app. And the cool thing is when you're going through these challenges, we teach you that exactly. Yes, we touch it. Oh yeah, I'm so sorry. And the question is if we're also going more into the theoretical part of it, like the math, and explaining that a little bit. I mean, I would say that's not a scientific paper you will get from us, but we're going to try to break it down so that you understand it. So, for instance, when it gets a little bit more complicated about CK, we'll show it later, but yeah, it's kind of breaking down. Yeah. And then coming from the over-collateralized lending, I mean, this is kind of the base in order then to have stable coins. And we also have a stablecoin challenge for that, because you can imagine you're having people putting in collateral, and against the collateral you can then mint some tokens, and that's, in this case, it's a stablecoin, and this price for the stablecoin you will get from Oracle, and that's kind of an over-collateralized stable loan then in the end. And that's also a thing that kind of builds on top of that, and from that we go in kind of this funnel, and we always attaching more things and make it more complicated. And then the next thing we're touching on, and that's actually pretty cool because you have a fully working prediction market, then is the next challenge. And in this prediction market, I mean, everybody knows maybe a prediction market, like it looks like here on Polymarket, where you can just bet on the different outcomes. And it's like a kind of a stock market, but for future outcomes. That's what you do with an end date, and you're always trading kind of some public events of interest. That's what you're kind of doing. And in these, I mean, I'm just gonna make it. I mean, here in these things, then you're gonna bring more things together. So we're having then the tokens. You need tokens. You need to trade for the yes and the no outcomes. You have a trading liquidity provision mechanism. So you need to make sure, okay, how can you then trade the tokens? So what are you going to go for? Is it the AMM from Uniswap we have before, or maybe we even build an order book because it's kind of maybe more efficient with market makers. So they are all things you then can try to think of. So you're building kind of this concept with the different things we're giving you, and then you can start to swapping these kind of things out. And then, and also very important part, what is kind of our last challenge, are oracles. Because it sounds very easy. In the beginning, you see, okay, it's just the right function on the blockchain. So I just take my data, and I just write it, send and call data to the blockchain, and it's there. But what is the whole mechanism behind it? What are the incentives behind it, and all these kind of things? That's actually getting pretty complicated in the end, when you go more deeper the rabbit hole in these kind of things. Yeah, and then the latest challenge I was just recently working on, and that's actually pretty cool, and that's definitely very worth taking it when you're at this point, is kind of the CK voting. So really having privacy on chain, because this is definitely a very important part, from my opinion, I see, and I mean many people, other people see, and we also have for that now a kind of a challenge. Because I mean the main issue with the security is that everything is kind of just transparent. I mean, it's good for the trust. You're seeing all the transaction. You can look in every protocol. You know exactly who put which address, which amounts in. But I mean, for your privacy, it's not the best, because just as soon as your address gets leaked, and imagine you have a salary on chain at some point in time, then your employer knows your address, and you're standing from this address to another address, you can just see exactly what are you spending, how much money you're making, how much money you saved, which meme coins you're trading, whatever. Everything is kind of on chain, and you don't want to have that. And in that, we kind of showing you, okay, let's take a mixer like Tornado Cash. I mean, that's kind of here. I just took the example out of the presentation I just gave recently on the Dev Connect about the CK voting. Yeah, but it's a mixer. We kind of built in here kind of a mixer and how a mixer works. Together with, I mean, I don't know how much time we have. I don't see. Oh, keep on. Yeah. Yeah. Just, I mean, the cool thing, I mean, I can talk about this a lot because this is really a topic I really like a lot, is like, a mixer is just you have a big group of people. They're all doing the same thing. And you're gonna put, like in a mixer like Tornado Cash, you're gonna use, they're all putting ETH into a pool, more or less. That gets mixed, so nobody really knows which ETH that is anymore. And because of the CK, like a CK proof, so the prover, that's kind of me. I know a secret, and I can prove that one ETH in this pool belongs to me without revealing which ETH that is. And because I'm taking this ETH then out in the last phase, in the withdraw phase, to a different separate address, the connection, what I mentioned before with the security, you know exactly where what goes, is kind of broken. And that's kind of the base how CK actually works. Also, when you go to add stack networks and make it more complex, yeah. No, I mean, how it works, it would now probably, that will take too long to explain, but the thing is, No, because you only put on-chain a kind of a commitment you have. That is kind of consistent, that's hashed of a secret and a nullifier. You only know. And these two variables, or these two parameters, they stay on your computer. So you just keep them. They stay off-chain on your client. There are. And you can't prove with a proof, because you have these two secrets, that this commitment belongs to you. And therefore, you're going to generate off-chain, so on your machine, the proof, and this proof gets then passed into the smart contract. And that's, you can imagine, it's just an if condition, more or less, where you're calling the verify function. And if this gives a true, it lets you go through the contract. Otherwise, it kicks you out and the whole contract reverts. And that's actually what we're kind of doing in that. No. That's exact. This is the zero knowledge proof thing. So that I'm, as a prover, can prove to you that I know the secret without revealing what the secret is. So you only know that I know it, but you don't know what it is. So if you imagine then, I mean, I just gave an example. So we're going in this challenge also more through Merkle trees, because they get very important, and then there are special forms of the Merkle tree, like this incremental Merkle tree. And what you actually do, as soon as you register, you do something, you're getting a leaf. This is all the way to the bottom kind of thing. You're adding to the Merkle tree. And what you're going to do, prove to the verifier that you know that you are one leaf without revealing what leaf you are. So in this sense, we have 5 people registered. I can tell you I'm part of this leaf, but you don't know who I am. If this makes sense. Yeah, and so on. And in here in the CK voting app, we do the registration with the Merkle tree, and we're gonna create CK circuits. We're gonna write them NOR, and this is actually pretty cool, because NOR makes it pretty easy to use CK nowadays. So it's actually there. And when you do this challenge, you will be definitely ready. You understand the core concepts of CK and how you could build apps around it. And that's pretty cool. I think for me, it was very eye-opening. In the beginning, it was like, Philip, you should do a CK voting challenge. And it's like, oh shit, CK, that sounds complicated. Actually, it is when you go very deep, but it's very good nowadays abstract away. So I think right now the time is ready to build some cool with CK, some privacy-focused applications. Yeah, and then we have, it's coming soon, it's not live yet, on Speedrun Ethereum, the different oracle challenge. About different ones, optimistic oracles, where you can just answer questions for prediction markets, more open-ended questions, or we have oracles where you can just deliver prices for Ethereum and so further. What is needed for lending and borrowing protocols, for instance, and so on. Yeah, maybe can I use your browser for a second? I just want to show quickly how Speedrun Ethereum looks like if you haven't seen it yet. Oh, you're scrolling a different way. No, all good. This is kind of the speedrun, and you see here all the different challenges, kind of tokenization, and which I mentioned. And when you go in here on the quest, then you see how it's structured. Yeah, but I think it's good to see. I mean, I don't want to go. So we have kind of an introduction, then we have different checkpoints, like the environment, and just going through, and you're getting all the commands to run these challenges. You just can go through. Yeah. Where is the presentation now, Kevin? Sorry for that. It's not my. Oh, here it is. Yeah, okay. Yeah, and the tech stack we're using, and this is done. Kevin, goes into it further, is Scaffold Eve. This is kind of this tool, and I will let everything to him, but it's pretty cool because it's one mono repo which has the front end and the contracts. Doesn't matter if it's Foundry or hardware together, and you can just very easily prototype, and even it works awesome with LLMs because they just know how the Scaffold Eve works. Yeah, I mean, I think I have said the most of it already. Yeah, I think that's it for the meantime. Maybe, Mike is good.
So with the stack you're proposing, is it, would you say like using Next is necessary, or like any JavaScript framework?
I mean, depends, huh? What you want, how it just depends what you want to do. I mean, of course, you can have your own stack if if you know what you're doing, you're just starting from scratch. You not even need a framework. You're just using React components. That would be also the other option. It's all good. I mean, the advantage is with Next, and there come some WACME components. They're already very nice. So you have already things that are there and you can use. And we built on top of that. So you have already components prepared. They're very easy to prototype. But of course, if you want to build a product from scratch, your own, and give it your own style, I mean, of course, then probably you won't go for that stack. Then you define your own stack and what you prefer. Yeah. Any other questions? I hope I didn't go through too fast through the concepts. So if there is any question.
So how come we use for a zero knowledge proof project scaffold?
Yes, you can use it.
Can I use it?
Yes. The only thing what you need to do is, because our scaffold Eth, when it comes out of the box and you install it, it only has some smart contract like Hardhat or Foundry installed and Next.js. And in order to write Nor, for instance, but it depends what zero knowledge proof language you want to use, kinda, you need to install that as well. So you have another package then in the monorepo you're using, the scaffold Eth.
Okay, thank you.
But you can definitely look, if you want, you can look at the challenge and how the challenge is set up, and it will really explain you already a lot, if you're interested. If you're interested, you can come later to me and I can answer some questions as well. There are any other questions? Otherwise, I would head over to Mr. Scaffold Eth. Oh, yeah, one more.
On the ZK vote part, in order to hide the identity of the voter, we're using a burner wallet, right?
Sorry, I don't get it.
In order to submit the vote, we're using a burner wallet.
Burner wallet?
Yeah.
Yeah, that you mean the last one, yes, exactly. Yeah, you need a completely fresh address for that. Because if you would use the same address, then the whole thing is for nothing.
Maybe is there a way like to send the vote to a relayer, like just like in Tornado Cash, and you don't have to pay the gas fee, and
yeah, it's a very
your wallet.
Yeah, how it's set up in there that you have a verifying paymaster. So you're gonna spin up a fresh smart account, and then a verifying paymaster pays for this transaction.
But the current approach is I have to use a different wallet.
Yeah, I mean, in how you will see it in the application. How this application, I mean, you can do it how you want, but in the application or in the ZK voting challenge, how it's done, you're gonna spin up a new smart account, so a fresh account with a completely new private key, and this one gets then sponsored from a verifying paymaster. So you only click vote, you don't have to do it in the back end, it just generates you a new smart account that gets then sponsored. This makes sense.
Yes, thank you.
Cool. Thank you so much. Oh yeah, that's your computer.
Alrighty, thank you guys. Thank you, Philip. That was great. Yes, Speedrun Ethereum is just a great resource. When I first started building on Ethereum, it was my journey myself. So personally, just love some of those challenges, and some of the newer ones are really, really good. So thank you. Okay, cool. So yes, my name is Kevin Jones. I work in developer relations for the Graph protocol at DigiNode. And I'm also in the Build Guild. I've been in Build Guild for a while now. It was my first journey into Ethereum. And again, Scaffold ETH was a huge part of that. So I'm going to give you guys kind of a run through on Scaffold ETH, talk a little bit about like all the tooling, how it works, how you can get started quickly. We do have a small group, which is great. So I definitely want to make this as interactive as possible for you guys, and make sure I answer any questions we have along the way and try to take our time here. But I'm curious, who here has used Scaffold ETH before in any kind of shape? Cool. So this is new crowd. This is great. This is you guys are the perfect customers for this presentation. So we're going to try to give a full walkthrough of how Scaffold ETH works. And for you guys that want to actually do this on your own, you can just go to scaffoldeth.io. That will bring you to this webpage. And there's one command that you need to have right here. And it's the npx create-eth at latest. And that's going to basically use the create eth npx script to spin up an environment for you, okay? So we're gonna just dive right into it and go ahead and build something. So when you first do this, it's gonna ask you to install it, right? So go ahead and say yes. You'll need to have Node.js installed on your machine, and you'll also need to have Yarn Package Manager because, and make sure you have the newest version of Yarn Package Manager because there can be some issues with like older versions. So if you have Windows or Linux, make sure you update it. And then you just need to name your app. So we're gonna call this Argentina. And it's gonna ask us what framework we wanna use. So we support both Hardhat and Foundry when you install. Really is up to you. I'm gonna use Hardhat because I've just been using it forever and I just too lazy to switch over to Foundry. Hardhat has a little bit more support, I would say, in terms of like history on the internet for like finding issues. But Foundry is a little faster. You can also write your deploy scripts and your tests in Solidity, which is sometimes nice for if you're really, really into Solidity and not so much JavaScript or TypeScript. Hardhat uses TypeScript or JavaScript for testing and deployments. So this is going to go out. It's going to install all the dependencies for your project. This basically is going to install everything that's in the package JSON. So Philip mentioned earlier, it is a monorepo, so it's actually got two different packages in there. It has the Hardhat or a Foundry folder, and then it has the Next.js folder. So depending on your internet connection, this might take a little while. Also here at the hackathon, there's probably a lot of people on the network. So just because it looks like it's not moving, I'm gonna go ahead, and I did this ahead of time, and I have one called foo, so I'm just gonna go in there. Okay, so I already did that. Let's just assume that I set up the project. The very first window that you need to do is bring up your chain, okay? So you can see here, I'm gonna do yarn chain. That's gonna basically spin up either Hardhat or Foundry, depending on which one that you installed. And it's gonna give you all of the accounts that come with it, right? As a kind of a console output. And then everything you do in Scaffold ETH, you need a couple windows open, actually a few windows, because you need to always have your chain up. So we're gonna keep that open so we can see what's going on. And then in this other window, we're gonna go into the same exact directory and start up our front end. Okay, so that's yarn start. Close this. So yarn start is gonna spin up the front end, port 3000, very easy. And then that's it. You'll keep those kind of open. That way you see if you have any errors with your front end or if you have any issues with the chain or console output, stuff like that. Then in this very last window, we're just gonna spin up and deploy our contract, okay? So to do that, all we need to do is do yarn deploy. So chain for the back end, start for the front end, and deploy, we'll deploy our contract. That's gonna give us some console output here, and it tells you exactly what your contract address is. It also tells you how much gas that it costs to deploy the contract, and then you can see we got some console log output as well up on the top. And so that's good. Everything seems to be working. We were able to deploy successfully. So let's load up Scaffold ETH here, okay? So again, Scaffold ETH is a React application. So we have it here on port 3000. And we're gonna go ahead and just test kind of the Scaffold ETH environment to make sure everything's working. So it might take a sec for it to compile. You'll know it's done when it has this little daisy UI thing right here. And you should be able to reload and it should start. For some reason, my computer's running a little slow, so there we go. Okay. All right, so here we are. We're inside Scaffold ETH. So it's a React application. I heard a question earlier was like, oh, do you need Next.js or do you need React? I like Next.js because it has a lot of like interesting stuff that makes it easy to build hackathon projects. Things like app router, things like the ability to do API routes if you want to deploy to Vercel. Like there might be things that are just going to make life a little bit easier for you in Next.js. And so that's kind of why we picked Next.js. We also picked Next.js over React because Next.js is a little faster than React was. And so there's a little bit less, I guess, overhead when it comes to memory. But here we have Scaffold ETH up and running. And we can go to this debug contracts tab. So that's kind of like the secret sauce of Scaffold ETH. This debug contracts tab keeps track of everything that is in the contract ABI, and it reads in all of the data types that are created for the ABI and the functions so that we can build a UI automatically. And so that happens here, like when you saw when we deployed our contract, you may have seen this line right here. What's cool is we actually run this script and we generate types for all of the definitions of the contract. And so what that allows us to do is have this unique page that automatically lets us start testing our smart contract. We don't even have to know any front-end code at all, and we can kind of assume that we know what the contract does just by looking here. So we have a contract that's called a greeting contract that's called your contract that has a string called greeting, and it has an owner address, it has a Boolean, which is a true or false, and it has a counter, which is an unsigned integer. And then we have this write function here that lets us update that, right? So we can go ahead and come in here and say Argentina, this. And if I hit send, it's not gonna work, and that's because I don't have any gas. But you'll notice up here we have a little burner wallet and a faucet. So we can just go ahead and grab funds from the faucet, and there we go. And now that we have 1 ETH in our account right here, we can go ahead and click send. There we go. And so now I was able to kind of like change that greeting, right? Super awesome. So nothing crazy, but we were able to really like test our smart contract without really doing any front-end code. Let's take a look now at, and by the way, you can also like reveal the private key here as well. So if you want to like export that into MetaMask or into some other wallet, you can do that. There's also a QR code, so you can like fund it from your phone. Super useful, just little things. There's also this like night mode and day mode switcher, which is really cool. But let's pretend that we want to write like a very basic hackathon project, right? So let's go back over here and load up this whole project in Cursor, okay? So I'm going to load up Cursor, and let's come in here, go full screen. There we go. Zoom in a little bit so we can see what's going on. All right, we're going to go to this directory, and we're going to look in the packages folder. And again, we see we have 2 different folders, okay? We have Hardhat, which is because we chose Hardhat, and we have Next.js. Hardhat's going to have all of the smart contract stuff. And so inside there, there's a contracts folder. And then inside that contracts folder is our smart contract. So if we were to come in here and look around, we would basically see the exact same stuff that we see here, but in code, okay? And what I want to do is just kind of show you how we make some changes. So I'm going to make a new address that's public called boss, like this. And then I'm going to make a new function that lets us change who the boss is, okay? So I'm going to do function set boss, takes an address, underscore boss, and we'll make it public, and we'll say boss equal underscore boss, I think. See if that works. Oh, okay. So we have this like new function that we've created, essentially. I think that should be good. I don't think we need to do anything else. Let's try to deploy our change. I saved it. All we need to do is come over here, redeploy. Make sure I did that right. There it goes. It deploys successfully. And so now if we come to Scaffold ETH and we refresh, we should get that information in our front end automatically. So now we have the boss, right? And we also have this ability to set the boss. So let's set the boss to ATG.ETH. Boom. Okay, so it did ENS resolution, which is really cool. So there are these components inside Scaffold ETH that I'm going to get to in a little bit that will automatically do ENS resolution for us, and it will give us the address back. And then we get his little like PFP, so that's Austin's address and his ENS PFP. And we were able to update him to the boss, right? So we kind of made this very basic smart contract that's just kind of like king of the hill type contract that anybody could come in and just set themselves as the boss. We also get like this little receipt, which is kind of interesting. Like it's basically the response from the JSON RPC so that we can see, you know, what happened, the hash, stuff like that. But let's pretend now that like we want to like build out a UI for this, right? How do we do that? Inside of this home folder right here, all this stuff that we see here is kind of like boilerplate code that is like very, very basic hello world code. And if we go now to our Next.js folder, we can see we have this app folder here, app. And inside there, there's this page.tsx file. So I mentioned earlier that we use app router with Next.js, and what that gives you is these like URL-based routes, so /block explorer or /debug, right? But then when you have this main page, this is the root of the application. So what I always like to do is just come in here, and there's a fragment defined right here, and that we make it easy. You can just grab everything that's inside the fragment right here, everything here, and just wipe that out, save that. And when you do that, that's going to just get rid of everything in the middle, okay? This way you still have your header, because you want to use that for your hackathon probably. You need a wallet connector, so you need the rainbow kit. You also need the faucet to test locally probably. You know, you probably want to have this cool little banner. You can like change your styling and stuff. You want to have this night and day mode, so that's cool. All this stuff you see on the bottom, but we want to just build the app inside of here, okay? So a couple things. First of all, we use Daisy UI, okay? So Daisy UI. And one of the things you can do with Daisy UI is you can just go to Daisy UI's website, hopefully it loads, and there's a list of components on there in this components right here. And you can just pick from any of those components and just copy and paste them into Scaffold ETH. So I always like to show off the card because it's pretty useful. Shout out to Etta, she always does this one too. She's also in the Build Guild, really good at demos. So if I grab this card and I go to JSX right here, I can just copy everything here. And so any component you find on this website, you can literally just come in here and paste it here, save it, and it will show up inside of Scaffold ETH in the same kind of styling, okay? So what I want to do is like incorporate all the functionality for my contract inside of here. So I need a place to figure out who the boss is. I need a place to input a new boss, type it in, and I need a button that says set boss. So I want to know who the boss is, and then I want to be able to change the boss, right? So Scaffold ETH makes it really easy to do that because there are two sections of the docs that I would recommend that you check out. So if you go to scaffoldeth.io and click docs right here, you'll get sent to this page. And there's a components section, and there's a interacting with your smart contract section. You'll kind of spend all your time in there. The components are really nice because they're just like reusable stuff that's in Scaffold ETH that looks really good, especially for like a hackathon. And they're things like address resolution that I showed you, right? Where you can just put in an ENS name and it will give you a copy paste button. There's also a balance checker that you can check the balance of an Ethereum address, right? Really useful. And it lets you toggle between US dollars. There's also an address input, right? This is what we saw earlier when you can type in an ENS name and it will resolve it for you. So all this stuff is really useful. But let's say we want to read data from the contract. How do we do that? Well, you could use WagMe directly, but we have a hook that is kind of always guaranteed to stay the same. So you don't really need to know when WagMe changes some weird stuff on the back end. We take care of all that for you, and we just give you this very simple hook, okay? And the hook basically says, this is the stuff I want to get, in this case, or I want to read from my contract. This is the contract name, that was if you have more than one contract, you would have multiple names. And then you call a certain function, and then you pass in certain arguments, right? So let's try to do that for the boss, okay? So we know we have this like boss variable. We want to put it inside of here. So what I'm going to do is go to the docs, go to read contract here, and I'm just going to copy all this right now, okay? And I'm going to paste it right in this application right here, okay? We're not getting the counter anymore. So what this is saying is like, okay, we want to get some data back from the hook, and we want to call it something. So I'm going to say current boss, and I'm going to use scaffold read contract. It's giving me an error because it's not installed. All I need to do is actually click this, do quick fix, and I can import it like that, and it will add it right here. And I can reference the contract, and I'm going to reference boss because anytime you define a variable with Solidity, you get a get function called, the name is the same as the variable, so we have that. Now I save it. I got rid of the arguments because we don't need to give it any arguments. That's all it is. And now I just want to display. I'm going to kind of clean up this code a little bit. I'm just going to get rid of that image. and I'm gonna say like, who is the boss? And I'm gonna get rid of this paragraph here, and I'm just gonna show the boss here like this. Okay, so now let's look at scaffold ETH. So what did I do? I got the info from the chain, so I queried it, but it's very ugly. So we probably want to wrap it in with that component that we have. So let's go over here to the address component, and we can see what that looks like. We just need to wrap it like this, okay? So to do that, we need to import the address component up here at the top, which we already have it actually. And then we need to wrap this in the address. So we'll do address equals like that. AI is helping me a lot. And now we'll go over here and then look. Did I save it? There we go. So it's a lot better, right? It's got the austingriffith.eth, and it didn't like the resolution. I don't know, there's something weird going on. I probably like broke something when I used AI. Let's see. Oh yeah, maybe just get rid of this. Thank you. Something with the wrap, yeah. Okay, so now I have this kind of like card. It's not centered or anything nice, but it's okay. Well, you guys are getting the idea. We have like, how much time do we have? We got like 5 minutes. Now I want to make a button that lets me update. Well, first I need to input to like put in a new boss, right? So I'm going to go here to use scaffold, I'm going to do input, address input. Here we go. So now I want to like make some state where I can put in a new address. So I'm going to copy that. Let's make some state real quick. I think we can just put it here. I think it needs to be at the top, yeah? No, it goes, well, let me grab this first and put this right below here. So set address, we call it set boss, like this. We also need the address input up top, so let me do that. Address input, there we go. And set boss, and then we need to pass in the new boss, but we need to have some state. So anytime you want to save stuff in state in React or Next.js, you need to like basically keep track of that. So I'm going to put it here. I think that's where it goes. And I need to also import use state, so I'm going to fix that. There we go. So now I have some state. This is not right, though. Sorry, this is wrong. That should be right. Okay. So now I have the ability to set a new boss by taking in some state. So then I could have this, the value should be boss, I think. Value address. Is that right? Oh yeah, boss. Oh my God, this is not working. Address input, on-change set boss. I have it installed. This should work. Let me see if it works. It might just be giving me errors, but it's something with my linter. Let's see. Okay, that might work. Let's see. Metallic.eth. Cool. Okay, it's working. It's getting some errors, but that's okay. I think it's working. So now I just need this button. I think it's my internet connection. It's a little wonky right now. So the next thing is I would probably make this button like actually set the boss to, right? Because we're keeping track of this, who we want to set the boss to. So then we would use the write contract hook. So I'm actually not going to do it because I want to show two things real quick, but there is a hook to write to the contract as well, and it's use scaffold write contract. And you can basically define your own like custom hook for every function that you want to use in your contract. So in this case, we say, well, we want to use the write contract async into a new function that we name whatever we want, and we want to call that specific contract. And then here is a button example of how we could like do that, how we could call that asynchronous function. And so this was just like an example of a button. So I would be able to just like copy that and literally just paste that in right here to replace this button. So you can see how Scaffold ETH has a lot of like front-end stuff to make it easy for you to hook up your contract. The docs are actually really good as well. So like if you get lost, you can easily go in there. But let's just say, for the sake of time, because I want to do 5 minutes to show you the last mile here. Let's say, thank you. Let's say we want to push this to a test net, right? Now we want to push this to, I don't know, base Sepolia or base. How do we do that? Well, first of all, we don't want to use the keys that come with Hard Hat or Foundry. So we need to generate a deployer. So we can do that with yarn generate. And this will generate a private key and store it locally for us in the machine. It's going to ask you to password protect it. So we can just go ahead and hit enter. Hit the password again. Obviously you should put a password. I'm just doing a demo. And then we can do, it'll give you an account address right here. And then I can do yarn account. And I can also get like a visualization of that, right? So I'm going to hit enter. So now I have this QR code. So what I'm going to do is just take this QR code, and I'm just going to send $1 to it on base. So I'm just using my phone, if it works. Oh, one more time. Okay, scan. There we go. Okay, so I'm going to send $1 here of base ETH. If I have $1, I should. Oh, that's mainnet. I want to do that. Wow, the internet is so bad right now. It's not working. Oh man, it's not working. For some reason, my wallet is not showing me the network name. Sorry, guys, one sec. Okay, so I haven't been having the worst internet connection here in Argentina. I don't know why. Everywhere I go, it's just bad. Let's try it one more time. Okay, send. Okay, here we go. There we go. Okay, let me just send $1. Okay. So base is super cheap. So you can deploy to base very easily. If it will actually like send. There we go. Okay. So I'm going to do a deploy here. But when I do the deploy, all I need to do is do -- network and do base. And we use VM to list all the chains. So we have all the chains that are in VM are going to be available in Scaffold ETH. I'm going to hit enter. Now it's going to compile my contract, make sure it's good, which it already didn't need to, and it's going to push and do a transaction on base if the internet works. Let's see. Nope, not working. So I think the internet's just bad. It's just not working, unfortunately. Let me try one more time with my phone. No, it's okay. It's fine. At this point, it's like let's see if it finishes. Enter. We're going to do this. I know it. I can feel it. We're going to get finished. Okay, now it's deploying. Okay. So now it's deployed, and then I can do yarn -- verify base. And then the very last step, so this is going to verify my contract. We provide, yarn verify -- network, Yarn verify -- network base. This will verify your smart contract, which you should do because it's just best practice. And the very last thing that you need to know is that Scaffold ETH has a config file that you can change the chain. So right here, the default chain is hard hat. If we come down into Scaffold ETH, there's a config file called scaffold config, and you can change that here on the chains dot whatever. We can change it to base like that, hit save, and now our front end will reconfigure to base. Something to note is you'll get kicked out of the burner wallet, and that's because we don't want to use burner wallets inside of a main network or even a test network because the private key is stored in the browser session for the burner wallet. So now we're kicked out. Then we'll want to use a normal wallet like MetaMask or Rainbow. So now we can connect, we can see we're on the wrong network, we need to switch to Base, and there we go. So now our app is fully deployed on Base. We can come to the who's the boss, and I didn't make the button work, but if I had made the button work, I would be able to come in here. I'll just do it this way. I'll set it to vitalik.eth and hit send. Oh, try it again, send. Waiting user confirmation. It's going to pop up a MetaMask thing, and then it should work. Cool. All right. We have 5 minutes for questions. So who has a question? Just raise your hand, and we can get you a mic. If not, if we don't have a question, I can finish maybe the button.
Will you both be at like booths or like mentors for the hackathons? Like, can we find you anywhere and like when? Yeah.
Well, I'll definitely be at the Graph booth because I work at the Graph. But yeah, just let us know. We'll be around for a while. We also have other guys, I think, probably coming later. So there's like 20 Build Guild guys here, I think, or like 15 around or something like that. So there's going to be some guys from Build Guild here. The best way to actually get a hold of us is if you just do a search for Scaffold ETH Telegram. There's a Telegram chat, and you can also ask in there, and you can probably find someone if for some reason you can't find anyone for help, and this will open up the Telegram chat. Yep, good question. Another question?
I was just curious about like the last part, like you switch from testnet and go to a real chain, but like why did you need to connect to your real wallet, and what's the difference to the contract that you send? I didn't get the part why you send $1 to that address and then you just connect to your MetaMask. Like what?
Yeah, sure, I can explain. Yeah, so inside the Scaffold ETH, the burner wallet that you're using, first of all, is just for testing. It's for like local testing as a user. Pretend it's like a user. You're like kind of simulating a user. When I did Yarn Generate, I generated a different private key and public key pair that was stored in my environment variable just to deploy the contract. So that's kind of like the owner of the contract. And the reason why I switched from my burner wallet to MetaMask is because you don't want to use a MetaMask or a burner wallet on a public network, because the private key is literally inside of developer tools. Like you can come over here and find it inside the storage, right? And we don't want that because you don't want someone getting your private key inside of here. So we go to session storage and somewhere in here, but yeah, the private key is inside here. And so it's just not secure. Does that make sense?
Yeah, thank you, got it.
Yep, no worries. Awesome. We have 1 more minute. Probably have time for one more question if anyone had one. No? Awesome. We'll build on Scaffold ETH, and thank you so much for hacking. Good luck, guys.